All right, team. We are starting. So, you guys have a resource sheet that is in front of you, and it says name, and it says ion identification right up for, and there's a long blank there. This is to help us keep organized which one we're doing. I will keep track of the unknowns that I'm giving you, so I have the answer key of which ions that you have. This is the exact same template that you guys are going to get on the assessment. So, just kind of keeping in mind that it is organized to be double-sided. The first side is writing your experimental steps, your observations, and identifying precipitates. The second half here is justification. So you see how there's step 1, your justification for step number 1. And then there's also equations if relevant. I only need to see equations for 2 instances. First, if there's a precipitate. The second one is if you have carbon dioxide gas forming. Everything else I don't need an equation for. Are you okay with that so far? Okay. What you guys will get when you have the assessment or any practice task is I'm going to give you a solution, and it is going to be unknown. There's nothing labeled. Well, there is some labeled on here. It says 1 molar sodium hydroxide, but it's definitely not sodium hydroxide that I put in there. I can tell you that now. It's unknown. There's no label on it, and we need to figure out what the anion is. We can do the exact same experiment. Sorry, we can use this same sample and figure out the cation as well, but we're going to focus on that on a different day. Now, what's going to happen is I'm going to have the unknown, whenever we have an unknown, stationed on a table, and you will have these pipettes, and you will be able to suck up your unknown into the pipette. So I would just fill it up to there, basically, and then I move it onto one of my spare beakers, so that way I have the solution ready to go. So that's what you guys are going to do to start with. I'll pause this so you guys can take some unknown, and then we can start doing our testing. Right here. Alrighty. So, we are doing the anion identification write-up for the anion teacher example. So that way you guys have one for your notes. Just checking I'm recording again. I am. All right. So, just grabbing my colors so we can color code. We want blue, we want red, and we want green. There we go. Ah, come on. Here we go. Okay. There we go. Everything I need. Okay, so looking at our assessment criteria, we are going to be basically covering number, I think, 3 through 10. Yes, 3 through 10. I only wrote 4 through 10. I meant 3 through 10. All right. So if you guys notice, number 3 is I can identify an unknown ionic compound by carrying out an experiment. So that is going to be these experimental steps here. So you need to write down step by step what you are doing as one of our achieve criteria. The other thing we need to be doing for an achieved is I can state my observations during an ion identification process. So you need to be able to do this bit here, observations. And the last thing that is an achieved criteria is, where is it? Number 7, I can identify what the precipitate is in a precipitation reaction. So you see how this last bit over here says precipitate if present. That is the last thing for the achieved criteria. So this first page here, you need to be filling out for the achieved. Second page here is now starting to get to that merit excellence criteria. All right. So if we look at our flow chart, and we're looking at the anion side because we're identifying an anion today, these are my list of potential anions that I can test you on. So it's one of these 1, 2, 3, 4, 5, 6 potential items. Are we okay with that so far? All right. My first step to figure out what I have is by adding red litmus to my unknown. So what you guys are going to do, and you're going to do this with me so we can learn together, is we are looking for the red litmus paper. We are taking one of the red litmus papers out. These are chopped into small pieces because you don't need the whole thing. And we are taking a little bit of our unknown, and we are adding it to see what color it changes to. Now don't use all of it. You don't need all of it. There you go. Has anything happened? Has anything happened on yours? No. All right, so first step, we are writing down that we added unknown to red litmus. And then my observation, what happened? Nothing. It stayed red. Red litmus did not change color. Do I need to write anything for my precipitate? No, because there was no precipitate. All right. So that is one of the steps for the achieved. Now on the back side is our justifications. We'll do our justifications as we are working, so that way you guys know how to do that. So first thing here, I'm just double checking where it is on my criteria. So you see on number 4, I can explain my process and how I identified the unknown ionic compound. That is your merit level 1. So this bit here, your explanation to your identification, that's going to be merit. And then the other thing that's going to be merit is going to be justifying it with solubility rules. And what's the last one? Balancing our equations. So in this step, I don't have anything equation-wise to write, but I can justify some stuff. So since the red litmus did not turn blue, what does it tell me? Nothing. Well, it does. Look at the flow chart. It's not hydroxide and it's not carbonate. What are these two things? Are they acids or bases? Bases, because bases would have turned the red litmus paper blue. So that's how I justify that step. So, unknown ion cannot be OH minus or CO3 2 minus because the red litmus did not turn blue. And OH minus and CO3 2 minus are bases, which would have turned it blue. I could probably have written that more concise. I am sorry about that. My brain is not functioning on all cylinders today, apparently. But that's basically what we're looking at for your justification. I know it's not these two ions because it's not turning their litmus blue. What it could still be is sulfate, chloride, iodide, or nitrate. Yeah, it's not that. And if you want, you can have a whole little list here of your potential possibilities. What else is there? 2 minus NO. Was it 2 or 3? 3 Cl. So what I've done in that first step is I've eliminated these two. These three are, or sorry, those 4 are still left. Does that make sense? All right, keep going? Yeah. Okay. So next step here on my flow chart says to do what? Add barium nitrate, and it's a new sample. So I get my beaker. I add a few drops of my unknown. And then I find my barium nitrate in my box. There it is. And I add a few drops there. Just a few drops. Do I see it causing any precipitate? No. If I want to double check, you know how you can double check? is if you have a sulfate, which I might, okay, here we go, sulfuric acid. So if I want to double check, sulfuric acid has sulfate, correct? So what if I want to do, if I just want to double check to make sure I'm okay, and I'm okay with giving you guys known compounds if you want to compare and contrast. That's a sulfate. Should hopefully precipitate. Why are you not precipitating? I need to grab a different sulfate. Oh, it's not precipitating this one either. Let me grab a sulfate. That's not that. I think there's a hole in this too. All right, let me just grab a sulfate from the prep room so that we can see what it looks like. Wait, am I doing it right? I'm just thinking. Hold on. Oh, am I grabbing the right thing? I was grabbing the wrong thing, guys. Sorry, my bad. That's why it didn't work. All right. Something to keep in mind is I am happy to give you guys other chemicals if you want to use it as compare and contrast. So if you're like, ooh, I don't see a precipitate, but I want to be sure that it's not sulfate, I'm happy to grab you a sulfate so you can double check it. So let's say you take sulfuric acid, and then you want to test it with the barium nitrate. That's what the precipitate should look like, right? But the one you guys had with your unknown and your barium nitrate didn't do that. Yeah? So we can be very confident to say there's no precipitate here. Does that make sense? So I am happy to grab you guys other reagents if you want to use it as a means to double check if you have the right response. Does that make sense? Do you want me to go through that again? I'm getting mixed messages from the tables. Do you want me to do it with that again? Or does that make sense? All right. So when we are writing up what's going on, we go new sample. Oh man, that's wet. Didn't realize that was wet. All right, so we had a new sample. Barium nitrate was added to unknown. Did we see any precipitate? Yes. No precipitate. And again, if you're not sure how to write this formula, remember it is on the flow chart. BaNO3 2 with the brackets. You got it right? All right, back page, justify it. So what was left over on our list was sulfate, nitrate, chloride, whoopsie, and iodide. Which one am I crossing off from that? Sulfate, because I noticed here that if it was a white precipitate, it would have been sulfate. So we could write down that we know that barium sulfate, would that be soluble or insoluble? Insoluble, based off of our solubility rules. So barium sulfate is insoluble. If the unknown was sulfate, a white precipitate would have formed. A white precipitate would have formed when barium nitrate was added. in this experiment, there was no white precipitate? Therefore, unknown ion is not anion, I should say, is not SO42 minus. So you see, we're justifying our reasoning, and that is the merit level. Do I have an equation to write?
Yes.
No. Did I have a precipitate? No. So no equation to write. That make sense? All right, give you guys some more time to write that down. And I'll get some more of my base. Not base, but unknown. If you need more unknown, go up and grab some. There. Nothing, I just crossed it out. I was going to write ion on it, now I should write anion. All right, keep going. Yep. Yes? Okay. So back to our page with our steps. If we look at the flow chart, I had no precipitate, so then what do? Add silver nitrate. Do I need a new sample? Yes, so I've cleaned out my beaker. I'm looking for what? Silver nitrate. All right, so I'm adding a couple drops of my unknown. I'm going to add some silver nitrate. Do I see a precipitation? Yes, I do. All right, let's write our step. New sample. Silver nitrate was added to unknown. And then I got a white precipitate formed. Right, do I know what that precipitate is right now? No, you do not. What have I eliminated? I eliminated nitrate. Yep. But because that precipitate formed, it could be chloride or iodide. Now, I do know chloride is a white color and iodide is a yellow color. When I look at this guy, what do you think? Is that yellow or white? It's probably chloride then, right? But we're going to double check it. All right, justification-wise, go on the other side. So, since a precipitate formed, oops. Cannot be NO3 minus. Why? Because all nitrates are soluble. We get that from the solubility rules. So I've given the solubility rules to you guys. All nitrate compounds are soluble. Yep. Now, when you guys are looking at your success criteria, one of the things is I can explain how I identified a precipitate using the solubility rules. That's a merit requirement. So all that justification stuff is getting you demerit. So I've ruled out nitrate. So it could be chloride or iodide at this point, right? Those are my two choices. Now we will come back and do the equation. So we do need to be mindful that I do need to do an equation here. So I'm going to put a star so I remember to go back to it. And we do need to identify a precipitate here. So I'm going to put a star next to it so I remember to do that too. Okay? All right, what is the next step that I need to do according to the flow chart? Add excess dilute ammonia to it. Do I need a new sample? Doesn't say new sample. So take what you got, add ammonia, and see if it dissolves. Make sure our goggles are on. Give it a good, swish around. Now, you may not be able to dissolve all of it, but you might be able to dissolve some of it. So if you can dissolve some of it, then I would say it's dissolving. What do you guys think? Starting to dissolve, isn't it? Yep. Do you want me to grab iodide so you can compare? We grab some iodide here. Alright, just grabbing iodide just so you guys can have a comparison. Whoopsie. So here's iodide. Alright, I'm going to add the silver nitrate. You see how this one has a different color tone to it? Chloride versus iodide. And then I'm going to add the ammonia to it. You see how in this case it doesn't have a change to it? Whereas this one, you notice how it's not as white. Do you agree with me? So this one has dissolved. This one has not dissolved. When you go to the flow chart, what does that tell you? Added excess, white precipitate disappears, white precipitate remains. Is it chloride or iodide that I have?
Iodide.
That's iodide. This is chloride. Yeah? Because you see how this one started to dissolve? If we add more ammonia, it'll probably dissolve even more. Oh, it stinks too. All right. Does that make sense to how we tell the difference between those two? Yeah. All right. So let's write that up. So we added excess. What? Move it? That better?
Oh, it smells like hairline.
Yeah, it does, because ammonia is it's a cleaning product. It's ammonia. No, waft. Don't sniff. Do that if you want to smell it. All right, add excess ammonia. And then we're going to write down as our observation what happened. White precipitate disappeared. All right. So we've narrowed it down now to chloride. So what ion do I have at the bottom? Chloride. Yes, figured it out.
Got it.
All right, justification time now. Oh, here we go. All right, this one here is now an excellence level write-up because explaining why your precipitates disappear is one of the excellence criteria. Okay? So, you guys were asking me this last week. Why are things sometimes disappearing? Well, they're disappearing sometimes because they are forming these things called complex ions. There's a whole list of complex ions. And I think, yeah. Actually, just go. Right. Oh, I've got to keep going with the notes. All right. Do you guys see how you have a list of complex ions here? So these are all the complex ions that will come up in this flowchart. Yeah? So complex ions, when they form, are soluble. because they're big ligands. So you know how we talked about ionic compounds being positive, negative, positive, negative, positive, negative? And it has that set 3D structure, and then if it dissolves, then it breaks apart that 3D structure. With the complex ions, they are forming quite extensive units. So the one that we are thinking about is like, for example, the silver and the not silver nitrate, silver, I don't even know what it's called now. The silver with the ammonia complex. So you see it'd basically be Ag, if I was to draw it out, NH3, NH3, and then it's going to have like a little a plus next to it. So this is now able to dissolve in water. So that's why we're starting to see that dissolving. The other thing to keep in mind is with the example of chloride, chloride can be displaced by the ammonia, but the ammonia cannot displace the iodide. So what happens here, in the iodide, silver iodide remains because the ammonia cannot displace the iodide, so it stays as a precipitate. For the chloride, on the other hand, the ammonia can displace the chloride, forming the complex ion. So we lose silver chloride. That's our justification. So let's actually go through here. So what was my precipitate over here, now that we know what it was?
Chloride.
Chloride, but what? Chloride with what? Chloride with silver. So the precipitate in this case was silver chloride. Now for this step, I want you guys to write the ionic formula, but also write silver chloride. Because if you get your formula wrong, I can still pass you with this. Does that make sense? So double check, nice little safety net. If you make a mistake with the ionic formula, I have to mark it wrong, but if you have written this down, then I can save you. Okay? So that's the white precipitate. That white precipitate disappeared because a complex ion has formed. They spell disappeared, right? Because, okay, displaced. So I said the white precipitate silver chloride disappeared because ammonia displaced the chloride, forming a complex ion which is soluble. The main thing to be mindful of that I'm looking for is that you understand a forming complex ion which is soluble. Are we good with that? All right, last step then is to put in our equations. So this one here, we put a star because we knew we needed to come back and put an equation in there. Remember, I don't want to have any spectators in there because if you put the spectators in there that are not involved in the precipitation reaction, that's just error, like potential places for you to cause error. Yeah? So we start our equation with our product, which is silver chloride, which is solid. If you want to double check yourself to make sure that you are linking, you can write that this is the white PPT. And I had silver, which is aqueous, plus chloride, which is also aqueous, coming together to form silver chloride. All right, last step. All right, our equation for this guy. So if you're wondering, what do I write for the equation over here? Look at your complex ions and think about it logically which one it could be. So we've decided that this one is going to be the silver with the ammonia, right? So let's write that down. AgNH3. 3, 2, square brackets, because we're talking about complex ion with a plus sign. That is aqueous. And in order to make that, I had silver plus 2 ammonias. And that's that equation done. Start with the end product, work backwards. Don't overcomplicate it. Aqueous. And that's it. Not too bad? Better. Better than what? All right. Are we okay so far? Questions, concerns, comments? No. All right, we got, did we end at 25 today? Am I right? Okay. We have 10 minutes, so you have 2 choices. You could either work on the SciPad pages that were assigned as homework, or I can give you another unknown to test. Okay? All right, I'll give you an unknown to test, and I'll give you another template sheet. Now, I've got 10 minutes, can you just wait? So, FYI, children, science department is very much over budget with our printing. So I printed off a practice sheet for you guys to do, but I don't think I'm going to be able to print anymore because you don't necessarily need the template printed, because you can just take a piece of paper and go experimental steps, observations, precipitates, and then just write it as is. And same thing on the back side, go justification, equations. So we might just start doing this on refill. Okay? Did we get that? Yeah, I figure that's fine. All right. I'll pass out another template. We'll call it anion unknown number 1.